Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your class 10th ICSE chemistry chapter number 4, analytical chemistry, and in this video we are going to see the second part, which is the action of ammonium hydroxide on certain metallic salt solutions. So in the previous video we have seen the action of sodium hydroxide on certain metallic salt solutions, and if you have missed that video, please do watch it because you won't understand what I am talking about in this chapter in this video if you have missed that video completely. Okay, that video has all the basics which you have to remember, which you have to understand, and then you can apply here, okay, in the next part, in the next concept. Okay, and after studying this concept, I am going to summarize both of these reactions so that it would become very easy for you to remember the things which you need to remember to solve some questions in your exams. And we are going to also solve some questions which have been asked in your previous year's examinations, so that you would get a hold of the questions and you would know how to apply the concepts in order to solve such questions. Okay, so without wasting much time, let's start and let's rock. Okay, now let's start identifying that which particular metal ion is present in which of these metallic salt solutions. But now here we are going to do it with the help of ammonium hydroxide. We have done it with the help of sodium hydroxide, right? And we are going to exactly follow the same method here also. Okay, so I'm going to start here with the colorless solutions, but now I'm taking the first colorless solution, second one and third one as well, and we will do it, okay, in one go only. So first colorless solution, I'm going to start with it. Same way, I'm going to add this NH4OH solution, okay, colorless NH4OH solution into this first colorless metallic salt solution, okay. And what I observe is I'm again getting a colorless solution, okay, and there is no precipitate formed, okay. Now what is this new thing, right? Till now, we have observed that whenever we are adding any reagent into this colorless metallic salt solutions or colored metallic salt solutions, we are getting some precipitate along with a colorless solution, right? But here, there is no precipitate at all in the first step only. So this means that there is something is not right, okay? Now, what actually is happening here, you can see this ammonium hydroxide. We all know this is a weak alkali, okay? So it dissociates, partially, right? So when we are having this NH4OH solution, we are having some ions of ammonium and some ions of hydroxide, okay, or OH minus ions. But this OH minus ions, the amount of OH minus ions which are present, they are not enough, okay, to form a precipitate. And we all know a precipitate in all these reactions is a hydroxide, okay, a hydroxide of metal, okay, so metal hydroxide. Now, when such thing is happening, out of these 6 metallic salt solutions, we know one is of calcium, another is of zinc, and third one is of lead, 2 are of iron, and 1 is of copper. But when such thing is happening, okay, and we are having such metallic salt solutions of calcium, zinc, lead, iron, and copper, then we have to remember that this happens in the case of calcium 2+ salt solutions. Okay, so this means that this metallic salt solution is having calcium 2+ ion, and this metallic salt solution is made up of a calcium salt which is having calcium 2+ ion and which is soluble in water. We know this concept, right? So now, but no need to take up any calcium salt itself, because why? See, if I'm taking a soluble calcium salt having calcium 2+ ion, but I know that no calcium hydroxide is going to form, because the amount of hydroxide ions which is present in this ammonium hydroxide solution is not enough to catch up this calcium 2+ ions and form a calcium hydroxide, right? They are not strong enough. You can remember in this way, okay? Their amount is not enough, okay? So we don't get any precipitate. So this is the reason. So maybe in your examinations, they may ask you a reason. So it's very simple. You have to just state in one line and it's clear. Okay. Now moving to the next colorless metallic salt solution. So again, I'm doing the same thing. I'm going to add NH4OH solution, colorless NH4OH solution, drop by drop, and what I'm getting is a colorless solution. But now we are getting some magic. Yes, we are getting a precipitate here, and this precipitate is of white color and it is gelatinous. Okay, gel-like. Now, moving ahead, when we are adding excess of NH4OH into this solution, okay, which is having a precipitate as well, what is happening? Super magic. This precipitate disappears. Okay, it gets vanished and we just simply get a colorless solution. Now, we all know if this is happening, this means that our precipitate is dissolved in this colorless solution. Okay, in this colorless solution, it is dissolved, and this means that it is soluble in excess of NH4OH. When we are adding excess of NH4OH, it is getting dissolved. So this means our precipitate is soluble in excess of NH4OH. Okay, so I'm writing precipitate soluble in excess of NH4OH. Simply, now we have to just build up the chemical reaction. Now we all know what we have to do is, first we have to remember that this entire process is happening. Now, which is this which is this PPT? Okay, what is the name of this PPT? First we have to remember this thing. So if this thing is happening when we are getting a white gelatinous PPT by adding drop by drop NH4OH in a metallic salt solution, and this white gel like PPT is getting soluble in excess of NH4OH. Okay, so this white gelatinous PPT, then this white gelatinous PPT is of zinc hydroxide. Okay. Now we know how to develop a chemical reaction from this. We know that the zinc hydroxide has Zn2 plus ions, and these Zn2 plus ions are coming from this metallic salt solution. So this means that our metallic salt solution has Zn2 plus ions, right? Now we have to just figure out a zinc salt which is having Zn2 plus ion and which is soluble in water. So now we should not waste much time. We have done all this exercise, okay, in the previous video. Okay, we have to go through the rules of solubility of salt and then we have to figure out a salt. So zinc sulfate, simply. Okay, now what is happening? This zinc sulfate salt, and what we are adding into it, this, see, hydroxide ions are coming from this ammonium hydroxide, right? Very simple. We have developed the two reactants. We have one product. Now we know how to write the another product. Simply, we know zinc and hydroxide are combining to form zinc hydroxide. What is remaining? Ammonium ions and sulfate ions. So it would form ammonium sulfate, right? Now, formula of ammonium sulfate, I hope you know how to write it. Okay, you have studied in your previous grade itself. Now, this ammonium sulfate which is getting formed, we know ammonium salts are soluble in water, and ammonium salts, here you have to remember that just like the sodium salts, okay, ammonium salts are also colorless. Okay, so you can now easily understand, see, this ammonium salt is soluble in water. This means that in this solution, okay, it is getting soluble. So that's why we are not able to figure out that this salt is present in this solution, and this solution is colorless. I have told you why it is colorless, because see, this salt is getting dissolved in this solution and this salt is also colorless. That's why the solution's color is colorless. Very simple. Now moving ahead, what happens? What is actually happening in the terms of reaction when we are adding excess of NH4OH? We know if the PPT is getting solubilized, this means that our precipitate is reacting with that excess of reagent, right? If this precipitate is reacting with it, then only it would get vanished. Correct? We have studied it in the case of NaOH. When we use NaOH, we know this thing. Okay, we have studied this thing. So what we are going to do, we are just going to figure out, we are just going to write the reaction of this precipitate with this excess of reagent. But now, in case of NH4OH, we have to take this second product as well in this reaction. Okay, so what I'm going to do is, I'm going to just write the reaction here. Okay, zinc hydroxide I am taking, and along with it, I am having ammonium sulfate in this reaction. Okay, it is also, both of them are reacting with this ammonium hydroxide. Okay, and what they are going to form is actually making this colorless solution. They are going to form a salt and water. Okay, so I'm just writing here water. Now which salt it is going to form? See, now this salt is like quite complicated. Don't worry about its nature and all those things. You are going to study about it in your higher grades. It's a coordination compound, actually means it is related to the coordination chemistry. Okay, basically. So this salt is, I will tell you the name, and you have to remember you have to write the formula with the help of its name. Okay, so not zinc, starting with tetraamine zinc 2 sulfate. Okay, this is the name. Sir, you would say, sir, this is a huge name. Don't worry, it's very simple to remember. See, tetra 4 amine, what you have to write is, amine here means this NH3. Okay, and there are 4 amine, the name suggests. Okay, so 4 amine I have written, tetraamine, zinc, so I have to write zinc ahead of that amine group. I would put a bracket here. Okay, and then after zinc there is sulfate, so I would just write here SO4. Okay, okay, so now let's balance it. So you have to carefully balance this reaction. Just with the help of trial and hit method only we are going to balance it. Okay, you have studied in your previous grade. What we are going to do is, let's start with this. Okay, from the product we are going to do it one by one by taking each element. So zinc, here it is 1 1. Okay, in the reactants also. Then nitrogen, 4 nitrogens. Okay, and here see, you can see here clearly there are 2 nitrogens. Okay, n into 2 nitrogens. Okay, and here there is 1 nitrogen, so 3 nitrogens. On this side here there are 4 nitrogens, so what I would do, I would here just write 2. So you see, 2 nitrogens and 2 nitrogens, 4 nitrogens, balanced. Then moving ahead, hydrogen, 3 4s are 12 hydrogens and 2 hydrogens, means 14 hydrogens in the product. Now in the reactant, again you can take a closer look. See, 2 hydrogens. Okay, then 4 2s are 8 hydrogens, so total is 10 here. Then moving ahead, again 2 4s are 8, so 10 plus, here till here it was 10. Now again here 2 4s are 8, means 8 hydrogens more, so 10 plus 8 18, and then plus 2 it's 20. So 20 on the reactant side, here it is 14, so I have to make it 20. So how would I make? See, 3 4s are 12, right? So now I have to just adjust in such a way that this hydrogens would become 6. See, would become 8, sorry. Okay, see, 3 4s are 12, 4 2s are 8. So 12 plus 8, 20. And here there are already 20. So balanced now. Okay, now moving ahead, sulfur is 1. So on this side also, see, you can clearly see sulfur is 1. Okay, oxygen 4, and ahead oxygen 4, 8 oxygens. So let's check, there are 8 oxygens, oxygens are not 2 oxygen. Okay, then moving ahead, 4 oxygen means 6 oxygens, and then again moving ahead, 2 oxygen means 8 oxygen. So oxygens are balanced. So in this way we have balanced it. No need to worry about it. Just keep your mind calm, cool, and then just balance it. Okay, so this is actually what is happening when we are adding excess of NH4OH. Okay, in our this solution, which is having a white gel-like precipitate of zinc hydroxide. Now you would wonder that why this solution is turning colorless. Then you should also know this thing. See, this salt which is getting formed, it is soluble, okay, and it is also colorless. So since it is soluble, we cannot figure it out here in the solution, and since it is colorless, that's why the solution's color is colorless here. Okay, after adding excess of NH4OH. So I hope it is clear to you till now, till this 2 salts. Now let's see about the third salt. Okay, now before moving to see the third colorless metallic salt, I just missed one thing. Okay, you may also miss in your examination, so please pay attention while writing the reactions. Okay, once you have written the reaction, don't forget to balance it. Now we have balanced this reaction, right? But I just forgot to balance this one. Okay, the same logic we are going to apply for balancing this hydroxide forming reactions, which we know, that is, see, 2 hydroxide ions are required, since here zinc hydroxide has OH twice, right? So this means this NH4OH should be 2, then only 2 hydroxide ions would come, right? So 1 zinc and 2 hydroxide ions forming zinc hydroxide. Now what is remaining? 2 ammonium ions and 1 sulfate ion, right? So see, 2 ammonium ions and 1 sulfate ion. It is balanced. Very simple. And one more thing, while writing this reaction, whenever the PPT is soluble, okay, if I would have missed writing the word excess here, okay, when you are using excess NH4OH or excess NaOH, while writing the reaction, you should not forget writing the term here excess of NaOH or excess of NH4OH, whatever you are using for writing the reaction in case when the precipitate is soluble. Okay. Now let's move ahead to the third colorless solution. So I am taking this third colorless metallic salt solution. Simply going to follow the same process, adding drop by drop NH4OH solution into it, and I am getting a colorless solution along with a white precipitate. Okay. Now here this white precipitate is chalky. Okay. The previous one was gel-like, gelatinous. Here it is chalky white precipitate. And when we are adding excess of NaOH into it, sorry, NH4OH, not NaOH. So what is happening? This white precipitate is not getting soluble. Okay, this white precipitate and this solution remains as it is. So we can just write precipitate insoluble, right? In NH4, in excess of NH4OH. Now let's try to write the reaction. So see, in such cases when we are getting a white precipitate, okay, which is chalky in nature by addition of NH4OH solution into colorless metallic salt solution, and this white precipitate is not soluble in excess of NH4OH, then this white precipitate, chalky white precipitate, is of lead hydroxide. Now from this we can clearly figure out that Pb2 plus ions must be present in this colorless metallic salt solution. Okay, and now we all know this process, right? And we would just develop or write a chemical reaction simply. OH minus ions are coming from this ammonium hydroxide, right? And we have to just figure out a lead salt which is having Pb2 plus ion and which is soluble. So let's not waste time. I'm just simply writing lead nitrate. We also know how to arrive at this salt, okay, by making use of the solubility rules and all those things, and then just writing the next product. Okay, don't forget to give this downward arrow for precipitate formation. Okay, this in the chemical reaction it is important. Okay, if at all I have missed in the previous reaction, you please put it. Okay, so precipitate is getting formed, so showing it by downward arrow, and the next product which is formed, we can just clearly figure it out. See, lead and OH minus are forming lead hydroxide. What is remaining? Ammonium ions and nitrate ions, right? So it would form ammonium nitrate. Now you know the formula, ammonium nitrate NH4NO3. Simply it's ammonium ions are having +1 charge, NO3 ions are having -1 charge. So no need of any extra ions on either case, right? One ammonium ion is sufficient for one nitrate ion. They are simply forming ammonium nitrate NH4NO3. Now this ammonium nitrate salt, we know ammonium salts are colorless. Just now I have told you the previous reaction, and these ammonium salts are also soluble. From the solubility rule, we already know it. So since they are colorless, since they are soluble, we cannot figure them out in this colorless solution, and since they are colorless, okay, that's why the solution's color is colorless. Okay, the remaining solution is colorless. Now in excess of NH4OH, our lead hydroxide is not getting soluble. So no need to, since then no question of next reaction itself. Okay, now simply we have to balance it. So 2 hydroxide ions here, we need 2 hydroxide ions then, right? So 2 NH4OH. Now we got 2 hydroxide ions. Okay, then what is remaining? See, 1 lead and 2 hydroxide ions. Okay, lead hydroxide. Now what is remaining? 2 ammonium ions and 2 nitrate ions. So they would simply form 2 ammonium nitrate, and the reaction is balanced. Okay, so in this way we are done with this 3 colorless metallic salt solutions. Okay, now let's see about the colored solutions. Okay, now let's try to find out which metal ions are present in this each colored metallic salt solution. So taking this first green colored solution, okay, pale green colored solution. So here, okay, solution. Now what I'm going to do is same addition of this colorless NH4OH, right? Solution drop by drop very slowly. What I'm going to get is I'm going to get a colorless solution and a precipitate. But this precipitate is of some different color, okay? Interesting color. See, it's of dirty green color, okay? So, precipitate is of dirty green, okay? Not nice green, okay? It has just like blackish shade. We have seen this same colored precipitate in case of NaOH as well, okay? So, now you would get a hint. See, the precipitates which are going to be formed after addition of the NH4OH drop by drop are same as that of the precipitates which are going to be formed in case of NaOH. Exception is just the calcium part, okay? Here in case of NH4OH, calcium hydroxide is not getting formed. In case of NaOH, calcium hydroxide was also getting formed, and we have studied it. It was the first reaction. It was giving a white precipitate, right? So precipitate's color is the same. No need to, means there are no different colors of the precipitate which are getting formed because precipitate is same. See here, dirty green precipitate means here the hydroxide which is getting formed is ferrous hydroxide. Same as that of the, when we have seen the same case of the pale green solution with NaOH, we also got a dirty green precipitate of ferrous hydroxide. So I have told you to make a big chart, right? And for this also I hope you are making a you have taken a big A4, A5 size paper and you are writing these reactions. And with the help of sketch pens or markers, if you would do it, it would be very useful for you to remember the colors, because when you do it actually, okay, so at that time there is more chance of you to remember it, okay. So now you can correlate the colors. It's exactly the same, okay. Colors of the precipitates are exactly the same in case of both NH4OH and NaOH, okay. Now moving ahead, when we are adding excess of NH4OH into it, what is happening? Here the precipitate, this dirty green precipitate is insoluble, okay. It remains as it is after adding of excess of NH4OH. Very simple. Let's just try to develop the chemical reaction then. So see here, we know this FeOH twice, ferrous hydroxide precipitate is getting formed. This means that here in this ferrous hydroxide, this Fe is here, in ferrous hydroxide, Fe2 plus is present, right? So this Fe2 plus is coming from this metallic salt solution, we know, and this OH minus ions are coming from this ammonium hydroxide solution, right? See, I'm writing it here, NH4OH, okay. OH minus ions are coming from ammonium hydroxide, and this Fe2 plus ions are coming from this metallic salt solution. This means our metallic salt solution has Fe2 plus ions. We have figured it out, right? Now let's just take a iron salt having Fe2 plus ion which is soluble in water. So I'm simply taking iron sulfate, okay. Then by using the rules and all those things, I have figured it out and I have taken this, okay. You can also go slowly one by one, because now you would be knowing the process, okay. So I have just written directly the salt. You know the process how I have arrived to this salt, okay. We have done it a lot of times. Now two reactants, one product we are having, okay. The precipitate remaining, the soluble salt is remaining. How we have to figure it out? See, iron and OH minus are forming iron hydroxide, right? Ferrous hydroxide. So what is remaining? This ammonium, okay, and sulfate. Okay, don't call it as iron hydroxide. It is not actually correct. You have to write it as ferrous hydroxide, okay, because Fe2 plus ion is there in this hydroxide. So ferrous hydroxide is getting formed, and what is remaining? Ammonium ion and sulfate ion would form ammonium sulfate. So just write the formula of ammonium sulfate, NH4 twice SO4. We know that these ammonium salts are colorless, they are soluble, and they are present in this colorless solution. That's why, and that's why this solution is colorless, okay. The upper part is colorless and this lower part is of dirty green PPT, okay. So upper part is colorless because of this NH4 twice SO4 salt, okay. Now we know that in excess of NH4OH, precipitate is insoluble, which means it remains as it is. So no need of writing the, no need of that next reaction itself. The reaction is not taking place itself, right? And just balance this chemical reaction and our work is done. So how to balance? 2 hydroxide ions, 1 iron. So 1 ion is here and 2 hydroxide ions we need. So yeah, I'm just writing here 2 NH4OH, okay. Just adjust that space, little space U. And then what is remaining? 2 ammonium ions and 1 sulfate ion. So see, 2 ammonium, 1 sulfate. That's it. We have balanced it. Now let's take this yellow colored metallic salt solution and let's try to find out the metal ion which is present in it. Okay. So how we are going to do it? By adding NH4OH solution first, drop by drop. And what we are getting is, we are getting a colorless solution, but here the precipitate is of reddish brown color. Okay, reddish brown. Okay, a new colored precipitate means a colored precipitate we are getting, and you can just match it. It is same like that of the NaOH. In case of NaOH also, it was the same. When we are adding NaOH in the yellow colored solution, we are also getting a reddish brown precipitate. The same we are getting in case of NH4OH as well. Okay, and this, in this solution, we are adding excess of ammonium hydroxide. What is happening? The precipitate is remaining as it is. This means our precipitate is insoluble. Very simple. Now let's just try to figure out the reaction. So for that, first we have to remember this thing, that when we are adding NH4OH solution in a yellow colored solution, okay, yellow colored metallic salt solution, and we are getting a colorless solution along with this reddish brown precipitate, and this reddish brown precipitate is insoluble in excess of NH4OH, then this reddish brown precipitate is of FeOH thrice, ferric hydroxide. Okay. Don't forget to give this downward arrow. Now, from this we can figure out which metallic ion is present in this metallic salt solution. See, in ferrous hydroxide, Fe3 plus ion is present. So, this Fe3 plus ion is coming. We know that this Fe3 plus ion is coming from this metallic salt solution, and OH minus ions are coming from this NH4OH solution. Okay, very simple. So this means that this Fe3 plus ions are present in this metallic salt solution. We got which ion is present. Now just we have to develop a chemical reaction. So I have written NH4OH. Now we have to figure out iron salt having Fe3 plus ion which is soluble in water. So simply I am writing ferric chloride. Okay, wherever in salt you are involved with a Fe3 plus ion, you would just start with ferric. Whenever a salt, okay, of iron, and in that salt ion is in Fe2 plus and iron is as Fe2 plus iron. Okay, iron is as Fe2 plus iron. Okay, not the same word I am repeating. So such salts we would start with ferrous. Okay, now here FeCl3 in this iron salt, our ion is Fe3 plus ion. Okay, so I am starting it with name as ferric chloride, just the same as ferric hydroxide, ferric chloride. Okay, and yes, we have developed the two, means we have written the two reactants. One product is ready. Now again moving ahead to the last salt which is formed. Okay, so the last salt we have to just, we know how to make it. 1 Fe, 3 hydroxide ions, right? When 1 Fe and OH minus ions are coming from here, and what is remaining then? NH4 plus ions and chloride ions. So ammonium ions and chloride ions would form ammonium chloride. And now let's just balance this reaction. So 3 OH minus ions should be coming from this ammonium hydroxide, right? So that's why we need 3 ammonium hydroxides. Very clear. Now what is remaining? See, 1 ion, 3 ammonium hydroxide. This is balanced. Now about this, see, 3 ammonium ions and 3 chloride ions would make 3 ammonium chloride. This is also balanced. Okay, both of them are balanced. So this is our balanced chemical reaction. Okay, that's it. And one last thing about this reaction, which you definitely already know, that see, this ammonium chloride is getting formed, right? Ammonium salt, soluble salt, we already know, and this salt is colorless. So see, since it is soluble salt, we cannot distinguish, we cannot figure it out whether it is present in this solution or not, right? We are not able to see it, and it is having, and it is colorless, right? So it is soluble in this solution, okay, the upper part of the solution, and since it is colorless, therefore the upper part is colorless. Okay, it is forming a colorless solution. Very simple. Now moving ahead to the last colored metallic salt solution, and this is a special case. Okay, so why I'm telling it is a special case, let's see it. So I'm making this bluish colored metallic salt solution. Very interesting solution it is. Now let's do the same thing with it also. Okay, it also has to go through the same process. Your special case, but not that special. Okay, you also have to go through the same process. We are going to add in you also the NH4OH solution, right? Colorless NH4OH solution, drop by drop first. And what we observe is the colorless solution and with a precipitate. Now this precipitate is of which color? You may have guessed it right. Okay, pale blue color. Okay, and when we are adding excess of ammonium hydroxide into it, what is happening? Magic. Okay, because when we are adding this into this test tube, okay, excess of ammonium hydroxide into this colorless solution and this pale blue PPT, we are getting a deep blue solution. Okay, very, very interesting. Now let's see what actually is happening. Okay, so first of all, we know that what we have to do is, first of all, we have to figure out which precipitate it is. So when we are adding ammonium hydroxide into this blue colored solution, not deep blue, but blue colored solution. Okay, and we are getting a colorless solution along with a pale blue precipitate, and this blue colored solution is a metallic salt solution, right? And this pale blue precipitate and this colorless solution which we are getting, we are adding excess of NH4OH into it, and we are getting a deep blue solution directly. There is no precipitate, no pale blue precipitate is present here. Okay, so we can simply say that the precipitate is soluble in excess of NH4OH, and such precipitate is of, we have to remember, copper hydroxide. Okay, you would have guessed it as well, right? Now we already know that this OH minus ions are coming from ammonium hydroxide, right? So from where this Cu2 plus ions of this copper hydroxide precipitate would come from? Very simple, it would come from this metallic salt solution, we know. So this means that this Cu2 plus ions are present in this metallic salt solution. Okay, very simple. Now we have to just figure out a copper salt having Cu2 plus ion and which is soluble in water. So I'm writing simply copper sulfate by using all that rules and all those things of solubility simply. Now moving ahead, we have to write another salt. Now copper and OH minus ions are involved in this copper hydroxide formation. What is remaining? Ammonium and sulfate. It would form ammonium sulfate simply, right? And this ammonium sulfate, we know ammonium salts are colorless and they are soluble. So that's why we are not able to make out in this colorless solution. Okay, that's why we are not able to make out in this solution. Okay, this salt is present because it is soluble, and since it is colorless, the solution's color is colorless. Okay, the solution above the precipitate. Now let's just balance it. Very simple. One copper and two hydroxide ions. See, it is here, there is one copper, but we need two hydroxide ions. So I'm just putting here 2 in front of NH4OH. And then what is remaining? 2 ammonium ions, 1 sulfate ion. So 2 ammonium ions, 1 sulfate ion. Already balanced. Now we have to move ahead and we have to see the next reaction, because in excess of NH4OH, something is happening. And what is happening? That's why I'm telling you the special case. That's why I'm telling you that this is a special case. We are getting a deep blue solution. Okay. Now, how we are reaching this deep blue solution? Very interesting to know. See, same process will happen. See here, the precipitate is getting soluble, which means that this precipitate is reacting with our excess of NH4OH. But along with this precipitate, this ammonium sulfate is also reacting. Okay, so I would write the reaction here. Okay, this copper hydroxide precipitate plus ammonium sulfate and excess of ammonium hydroxide. Okay, so this excess of ammonium hydroxide is reacting with both of them, not just the precipitate but this salt as well. And what is happening? We are getting a same type of salt which we have observed in case of zinc. Okay, what was the name? Now you would remember it. Tetraamine. Now there it was zinc to sulfate. Here it is simply copper to sulfate. Okay. So now why I told that you would remember it, because same type of salt is getting formed. So this would help you to link back to the zinc part. Okay. So same way, tetraamine. So Amine is NH3. Tetra means 4. So tetraamine. Okay. Copper, we would write ahead of it. And then sulfate, we would put a bracket and would write after this. Amine. Okay. Amine. Okay. So this is the salt. And what else is getting formed? Water is getting formed. Very simple. Now just balance this reaction. Now you pause it here and you try it yourself, because we have balanced a lot of reactions. And this type of reaction also we have balanced earlier. Okay. So just pause it here, balance it. Okay. So I hope you would have tried it. So simply here 2 ammonium hydroxide are required and 4 water molecules are required. Okay. So if you had balanced correctly, you would get the same equation. Now coming back to this interesting deep blue solution. Why is this deep blue solution? And now you would figure out that why I'm again and again telling you that this solution is colorless, because of this salt and all those things. Because here the salt which is getting formed, okay, this salt is also soluble. That's why we are not able to make out, that's why it is not forming a precipitate. Simply it is getting solubilized. Okay, that's why we are not able to see this salt at all, since it is soluble, first of all. And second thing, this salt, okay, is having a blue color, okay, which is deep blue actually. And because of this deep blue color, okay, actually this salt, because of this salt, the deep blue color is getting formed, okay, here. Now, no need to go into the details of this coordination entity. Okay, no need to worry about it. Just you have to remember that this salt is soluble, and because of this salt only, okay, we are getting a deep blue solution, because this is getting solubilized, and because of this we are getting deep blue color in this solution, since it is also having a deep blue color. Very simple. Now, rest is water. So we know it plays only just the role to form the solution. Okay. Now you have to just remember these 2 reactions in this case, and your job is done. Okay. So far friends, we have studied the action of ammonium hydroxide, right, on the metallic salt solution. And in the previous video, we have studied the action of sodium hydroxide on metallic salt solutions, right? But you are having that those big 2 charts with you, correct? In order to understand those things, I have told you to make a big chart, a colorful chart. Wherever it is required, you use the colors. So beyond that chart, now I want to make the things much more easier for you. Okay. So I want you to know that you have to perfectly remember some things, okay, which are very important. And apart from those things, whatever are the rest of the things which we have studied so far, you can make out on your own, because you know the concept. Now, which things you have to perfectly remember about these 2 types of reactions is in this summary. Okay. So you have to just make like this summary, just like I have made it. Okay. One by one, we would see which are those 3 things which we have to remember perfectly about these reactions. Rest of the things you can build up on your own, because now you know the concept, right? So first of all, you have to remember the colors of the salt solutions, the metallic salt solutions which we have dealt with. Okay. So first of all, calcium salt solution, zinc salt solution, and lead salt solution having Ca2+, Zn2+, and Pb2+ ions. These are colorless, you know. Okay. So I am just summarizing it. Okay. Then the ferrous salt solutions, ferric salt solutions. Okay, the ferrous salt solution is having pale green color. I have deliberately written it with the same color so that it would be easier for you to remember. Okay, the things which we see with our eyes very much, these things which we visualize and see with our eyes, okay, those things get captured in our brain easily. So that's why you also make use of such colored pens, so it would be easy for you to remember. Okay, so ferrous salt solutions are having pale green color. Ferric salt solutions are having yellow color. Copper salt solutions, okay, having Cu2+ ions, are having blue color. Very simple. Second thing, when we are adding NaOH drop by drop into these metallic salt solutions, what is happening? We know precipitate is formed and soluble salt is formed, right? Precipitate and soluble salt. So we have to just write the precipitate's name. Soluble salt you can figure out when you know the particular salt, okay, in that particular metallic salt solution. And I have told you everything about it, how to figure out that salt, the solubility rules and all those things, okay. Most of the time in your examinations, they themselves give you the salt, okay, the soluble metallic salt. You have to just write the reaction. You have to just think on the other things, not about that soluble salt, okay. So what is happening when the calcium salt solution is treated with sodium hydroxide drop by drop, okay, the precipitate of calcium hydroxide is getting formed, see, okay. and a soluble salt is getting formed, right? Then you have to just write the color of the precipitate. We know calcium hydroxide's color is white. Simple. Then the zinc salt solution, when we are treating drop by drop with sodium hydroxide, okay, what is happening? Zinc hydroxide precipitate is getting formed, okay, and a soluble salt is getting formed. Now, the zinc hydroxide precipitate's color is also white, but you have to remember it is gel-like, okay. In order to distinguish between these three precipitates, okay, we need to remember the nature of the zinc hydroxide precipitate as well, okay. So, zinc hydroxide precipitate is white in color and gelatinous, gel-like in nature. Then, the lead salts, when we are treating it with sodium hydroxide, drop by drop, okay, this lead salt solution, what it is giving us? Lead hydroxide, same having white color, but the nature is chalky here. And along with it, the soluble salts are also formed. Okay, same with the case of zinc salt solution, soluble salt was getting formed along with the hydroxide. Lead salt solution also, soluble salt is getting formed along with the hydroxide. Very clear about these three things. Moving to next, ferrous salt solution, when we are treating it with NaOH drop by drop, they give us ferrous hydroxide having dirty green color. Okay, this is the precipitate and the soluble salt. Same way, ferric salt solutions, when we are treating it with NaOH drop by drop, they are giving us ferric hydroxide, okay, precipitate, which is reddish brown in color, okay, and a soluble salt. And the copper salt solution, when we are treating it with NaOH drop by drop, they are giving us copper hydroxide precipitate along with a soluble salt, and the color of this copper hydroxide precipitate is pale blue. Okay, so see, two things we have remembered very much clearly. Now, moving on to the third thing. So, I have told you, along with the precipitates, you have to remember the color, and where in case where you have to remember the nature as well, you have to remember the nature as well. Okay, now third thing which you have to remember, that's it, and then our job is done, which is the action of excess of NaOH on these precipitates. What is happening to these precipitates when we are adding excess of NaOH? So, firstly, calcium hydroxide precipitate, what is happening when we are adding excess of NaOH? It is getting sparingly soluble. Okay. Then we have studied zinc hydroxide precipitate and lead hydroxide precipitate, both of them. Okay. When we are treating it with excess of NaOH, okay, or when we are adding excess of NaOH, what is happening to them? See, I have made a box around them. So, both of them get vanished, gayab, and they form the salts. We have to remember just the salt's name so that you can develop the reaction on your own. Okay. So, what are these salts? Zinc hydroxide is forming sodium zincate, lead hydroxide is forming sodium plumbite, and along with the water. So, you can write the reaction on your own. Zinc hydroxide plus NaOH gives sodium zincate plus water. Lead hydroxide plus NaOH gives sodium plumbite plus water, right? Same way, you know the calcium, zinc, lead, ferrous, ferric and copper salt. This salt plus NaOH gives us hydroxides plus soluble salt. So, the reaction part is also very much easier. Just then you have to balance it. That's the only work you have to do. Okay. Next is, now see, in this NaOH case, only zinc hydroxide and lead hydroxide are forming the soluble salts. Okay, which means zinc hydroxide and lead hydroxide are getting soluble. That's it. Rest all the hydroxides are insoluble. You have to remember this. Okay, just this one thing you remember, and the third thing which you have to remember, that is what is happening to these precipitates in the excess of NaOH. That would be easier for you. Okay, now you know that zinc hydroxide and lead hydroxide get soluble, so you know they would be forming some salts and water. Okay, now moving ahead, this ferrous hydroxide precipitate, ferric hydroxide precipitate and copper hydroxide precipitate, all these precipitates, okay, whenever we add excess of NaOH into it, they remain as it is. They are insoluble. Very simple. Okay, the same way we saw the summary for the action of NaOH on metallic salt solution. Now it's time to see the summary for action of NH4OH on metallic salt solution. So I won't repeat this part, okay, because it remains same. The colors of the salt solution, it remains exactly the same, okay, for NaOH as well and for NH4OH as well, because we are not using some other salts, we are using the same salts. So the salt solutions colors are also exactly the same. Okay. Now let's move on to the second point. What happens to these salt solutions when we are treating it with the ammonium hydroxide drop by drop? So same way. Now calcium salt solution, when they are treated with ammonium hydroxide, they are not giving us any precipitate, right? We have studied this. Now quickly you write the reason about it, okay, for your reference. Why is it happening? Why calcium hydroxide precipitate is not getting formed? Because enough hydroxide ions are not getting produced itself, okay. And why is this happening? Why enough hydroxide ions are not getting produced? Because ammonium hydroxide, we have studied in the previous chapter, acid, bases and salts. Ammonium hydroxide is a weak alkali, so it doesn't dissociate completely. So that's the reason enough hydroxide ions are not getting formed. Okay, moving ahead, the zinc salt solution when treated with ammonium hydroxide, they give us zinc hydroxide precipitate, exactly the same type of precipitate as we were getting in case of NaOH, right? And some soluble salt. And here zinc hydroxide precipitate color is white and gelatinous, exactly the same thing. Okay, no change, same as light of the NaOH part. Then lead salts, when we are treating it with ammonium hydroxide, okay, they are giving us lead hydroxide precipitate and some soluble salt. And here lead hydroxide precipitate's color is also white, nature is also same, chalky. Okay, this won't change because see, zinc hydroxide would remain zinc hydroxide whether you add NaOH or NH4OH. If zinc hydroxide is getting produced, the nature and color would be the same only. Very simple. Now moving ahead, the ferrous salt solutions when treated with ammonium hydroxide, same ferrous hydroxide precipitate of dirty green color would be formed and some soluble salt. Same case, ferric salt solutions when treated with ammonium hydroxide, drop by drop, ferric hydroxide precipitate would be formed, reddish brown color and some soluble salt. Okay, and then the copper salt solutions when we are treating it with ammonium hydroxide, drop by drop, we are getting copper hydroxide precipitate and some soluble salt, and the copper hydroxide precipitate's color is pale blue. This part is exactly the same. Just you have to remember, calcium salt solutions with ammonium hydroxide is not giving us any precipitate. Okay, but in the case of sodium hydroxide, yes, it was giving us the precipitate. Okay, and I have denoted the same color for the soluble salt as well. This doesn't mean that the soluble salts are also dirty green, reddish brown and pale blue. I have told you these soluble salts are actually all of them are colorless. Okay, because these would be formed of ammonium ion, and I have told you ammonium salts are soluble as well and they are colorless as well. Okay, so you can just denote these soluble salts with a normal color. Don't use the same color as that of the precipitate. Now the third thing, now we have seen the second thing. See, the formation of precipitate, which precipitate is getting formed and soluble salts are getting formed, and this precipitate's colors as well. Okay, along with their nature. Now third part you have to remember is same like that of NaOH. What happens to these precipitates when we are adding excess of ammonium hydroxide? So first case is like whenever no precipitate is getting formed, and if at all we are adding excess of ammonium hydroxide into this calcium salt solution, okay, what is happening? Again, no precipitate, no change. Okay, same way. Now when we are moving ahead to the zinc hydroxide, same way when we are adding excess of ammonium hydroxide into this zinc hydroxide precipitate, again this is vanished. Okay, and it is now forming this tetraamine zinc 2 sulfate salt, okay, along with water. Now I have told you the reaction. So see, zinc hydroxide and along with it the soluble salt is also reacting with excess of ammonium hydroxide, right? Zinc hydroxide along with it the soluble salt, see, soluble salt and ammonium hydroxide. Okay, in this reaction these are the reactants. Okay, this ammonium hydroxide reacts with both zinc hydroxide and the soluble salt, and it forms this salt, tetraamine zinc 2 sulfate, along with water. And this salt is soluble. That's why we are not able to see the precipitate. Okay, the precipitate is getting vanished because this precipitate is forming a soluble salt. Clear? So you can have to write this reaction aside. Rest thing is you have to just balance it whenever you are writing it in your exams or somewhere else. Okay, it is not balanced here. Okay, I haven't balanced it because it's just for reference, right? It's a summary. So we are trying to make it crisp. Next is lead hydroxide precipitate. Now this precipitate adding excess of NH4OH, this precipitate doesn't get vanished. Okay, it remains insoluble. Moving ahead, same way, ferrous hydroxide and ferric hydroxide precipitates. Okay, they also are insoluble in excess of NH4OH. Just the case of copper hydroxide is different. It is same like that of the zinc hydroxide. See, okay, it is also forming a soluble salt, this tetraamine copper 2 sulfate, along with water when we are adding excess of ammonium hydroxide into it. So how is the reaction? This precipitate would come, excess of ammonium hydroxide would come, okay, and along with it this soluble salt is also reacting, which is getting formed. These are the reactants, these are the products, the salt and the water. And because of this salt, very important, this is the special case I have told you, deep blue solution is obtained. Okay, deep blue colored solution is obtained. So in the case of excess of NH4OH, what you have to remember is the zinc hydroxide precipitate and the copper hydroxide precipitate. These two precipitates are only getting soluble. Okay, in case of NaOH, zinc hydroxide precipitate and lead hydroxide precipitate were getting soluble. So how you can remember this? A simple trick I can tell you, see zinc hydroxide and copper hydroxide. Both of them are forming same type of salt. See, tetraamine zinc 2 sulfate, tetraamine copper 2 sulfate. See, amine comes here. This means that these are the salts which are formed when we are adding excess of ammonium hydroxide, right? The previous case was, see here, zinc hydroxide and lead hydroxide. Both of them, okay, are forming sodium zincate, sodium plumbite. So the names of the salt and the salts which are formed would give you a hint. Okay, see, sodium zincate and sodium plumbite. If you would remember these two salts are getting formed, you would ultimately remember that this zinc hydroxide and lead hydroxide are getting solubilized, right? In the same way, if you would remember these two salts, okay, tetraamine zinc 2 sulfate, tetraamine copper 2 sulfate, you would remember that yes, zinc hydroxide and copper hydroxide precipitates are getting soluble in case of ammonium hydroxide. Okay, since there is amine here. Very simple trick. Okay, now it's time to see some questions. So what I have done is from 2017 to 2020, okay, of this 4 years ICSE examination question paper, I have just analyzed it thoroughly and I have tried to include the different types of questions, okay, which have been asked based on these two concepts which we have learned so far, the action of sodium hydroxide on metallic salt solution and action of ammonium hydroxide on metallic salt solutions, okay, so that you would be exposed to different types of questions which have been asked on these topics and you would get an idea that how you have to apply the concepts which you have learned so far in order to solve some questions, okay, in order to solve the questions in your exams. So first one is state one relevant observation for the following reaction. Now this was asked in your 2020 exam. So what observation we have to write down is, for this reaction, see, addition of excess ammonium hydroxide into copper sulfate solution. Okay, so just now we have studied it, right, in the chart. When we are adding in now copper sulfate solution, okay, so mostly they won't give you in a question, they won't give you a metallic salt solution, okay, of such a metallic salt which is insoluble itself, okay. They would always give you a metallic salt solution of a metallic salt which is soluble in water, because they won't give you a wrong question itself, okay, for writing the observation, okay. So see, copper sulfate, it's soluble metallic salt and we can make its solution as well, okay. It dissolves in the water and it forms a solution. So this copper sulfate solution, we know this is a copper 2 plus salt solution, right? In copper sulfate, copper is 2 plus ion, okay, CO2 plus SO4 2 minus, right? So now we know that copper 2 plus salt solutions which are blue in color, okay, we have to just scan the summary inside our brain. So copper 2 plus salt solution blue in color, when we are adding ammonium hydroxide into it, okay, drop by drop, I'm just writing D by D. So what was happening? Copper hydroxide precipitate was getting formed and a soluble salt was getting formed, okay. Now when we are adding again excess of ammonium hydroxide, what was happening? This copper hydroxide precipitate was getting soluble and it was resulting into the formation, and it resulted into deep blue colored solution, right? That's it. This is our observation. See, we are adding excess of ammonium hydroxide into copper sulfate solution. So we just skipped this step. We are not adding drop by drop. In this copper sulfate solution, we directly added excess of ammonium hydroxide. What is happening? Actually, copper hydroxide precipitate is getting formed, and then this copper hydroxide precipitate is getting dissolved and forming a deep blue colored solution. Okay, so it is going actually step by step, but they are asking us directly the last step solution. Okay, what is happening at the last step, not in the first. So we know what is happening in the last step. Okay, by going step by step, we can figure it out. First of all, by adding drop by drop, the copper hydroxide precipitate is formed, and then we are adding excess of NH4OH. This precipitate gets dissolved, it is soluble, and results into the formation of deep blue colored solution. And this is our observation, right? You would observe this only. First, you would observe this pale blue precipitate, okay, when you would add drop by drop. And then, after adding excess, you would observe a deep blue colored solution. So simply your answer would be a deep blue colored solution is formed, right? So I'm writing here itself. deep blue colored solution is formed. Okay. Next one is write a balanced chemical equation for the following. So they are simply just asking you to write a reaction. And now we have studied it, how to write the reaction. They have given us the reactants as well. See, reaction of lead nitrate solution with ammonium hydroxide. So lead nitrate, all nitrates are soluble, right? So they won't do a mistake. I have told you, na, they won't give you such a salt, metallic salt, which is insoluble in water. Okay, because they are giving us the word solution as well with it. So absolutely, this salt would be soluble. This salt would be soluble in water. But I have told you that concept in order to make you aware about the things. Okay, which metallic salt solutions we are studying about. Okay, so here lead nitrate solution. So I'm just writing the reactant because we have to write the balanced chemical equation. Okay, so lead nitrate solution is reacting with ammonium hydroxide. Okay, what is happening? We know lead hydroxide precipitate is getting formed and a soluble salt is getting formed. Now we have studied it so many times, right? And soluble salt, which soluble salt is getting formed? How we can figure it out? See, lead and hydroxide, okay, are forming lead hydroxide. What is remaining? Ammonium and nitrate ions. So it would form ammonium nitrate. Very simple. Now we have to balance it simply. So 2 hydroxides. Here there comes 2 hydroxides. Then 1 lead. So see, 1 lead and 2 hydroxides are balanced. Oh, now what is remaining? 2 ammonium ions, 2 nitrate ions would form 2 ammonium nitrate. We have written the balanced chemical equation. That's it. Then next is identify the substance underlined in the following case. Okay. Which is the substance? Cation. And what's the question? Cation that does not form a precipitate, okay, with ammonium hydroxide, but forms one with sodium hydroxide. Okay, now this was asked in 2017. Previous one was asked in 2020. Okay, so how to solve this now? See, they are talking about a cation that does not form a precipitate with ammonium hydroxide, but forms a precipitate with sodium hydroxide. Now it's very simple. You just try to remember. Okay, we are here talking about the metallic salt solutions, and these metallic salt solutions are having metallic ion, right? The starting point which we have studied. So that's why I have told you the concept, because without the concept, you won't be able to answer the questions without understanding it in detail. So see, now they are talking about a metallic salt solution actually which is not forming a precipitate with ammonium hydroxide, but it is forming precipitate with sodium hydroxide. Now, how I could figure out? Because I know in this metallic salt solution, there is a metallic ion, and metallic ions are cations, right? Very clear. So, now which metallic salt solution doesn't give precipitate with ammonium hydroxide, but it gives precipitate with sodium hydroxide? The first one, calcium salt solutions, right? And these calcium salt solutions are having Ca2 plus ions, right? Ca2 plus ion is a cation. We got our answer. See? Okay, so this way you have to run your brains and you have to answer the questions. You have to use the concept. Okay, so next question is distinguish between the pairs of compounds using a reagent as a chemical test. Okay, now this was asked in your 2020 exam. So pair of compounds, which two compounds are given to us? Calcium nitrate solution and zinc nitrate solution. Okay, now see, in exams you would be given many questions like this. And at that time, you have to think, okay, because you have studied entire chemistry. And in that question paper, you won't be given that this question is from analytical chemistry. So students solve according to it and all those things. Okay, you have to use your brains at that time. Now, you know, you have studied this chapter. Now we are going to see how we are going to apply the concept on this question. Okay, but at that time, you need to think on your own that by seeing the two compounds which are given to you, how you can distinguish between them. Which concept you can apply to distinguish between them. Now here we know we are going to apply the concept which is the action of NaOH and action of NH4OH. So what we are going to do is simply here we are going to first of all think that what would happen or what is the action of calcium salts on NaOH and zinc salts on NaOH. and calcium salts on NH4OH and zinc salts on NH4OH. So we are taking a reagent. First I will take NH4OH. Okay, suppose ammonium hydroxide. Now I would just try to figure out what would happen when I am treating ammonium hydroxide with calcium salt, ammonium hydroxide with zinc salt. Okay, let's see. So we know calcium salt, when we are treating it with ammonium hydroxide, it doesn't form any PPT, right? We have studied this in the summary itself, right? And zinc salt, when we are treating it with ammonium hydroxide, drop by drop, we are getting a zinc hydroxide precipitate. That's it. Okay, we got the difference. Now this zinc hydroxide precipitate, how it is? We know it's white in color and it is gelatinous. So what you would observe is, okay, we have to write the same thing in the answer. What you would do in order to distinguish between these two salt solution, you found out by adding ammonium hydroxide into it. Okay, calcium salt solutions won't give me any precipitate, but zinc salt solution would give me a white gelatinous precipitate. So I could figure out that the solution which is giving me white gelatinous precipitate is of zinc salt, which means it is of zinc nitrate. The solution which is not giving me any precipitate is of calcium salt, which means it is calcium nitrate. Simple. So I have to write the same way in the exam. Add ammonium hydroxide solution in both of them, both of the test tubes, one having calcium nitrate, one having zinc nitrate, and one which gives gelatinous white precipitate. See, okay, this solution is of zinc nitrate. This is zinc nitrate solution, and the one which gives us no precipitate, okay, is of calcium nitrate solution. Very simple. Now using sodium hydroxide, we would try to distinguish between these two compounds. So first of all, let's see the action of sodium hydroxide on these two salts. So with the calcium salts, sodium hydroxide, yes, they form precipitate. Okay, when we are adding drop by drop, they form calcium hydroxide precipitates. Okay, now this precipitate is white in color, we know. And when we are adding drop by drop NaOH in zinc salt solutions, it also gives us zinc hydroxide precipitate. Okay, now this precipitate is also white in color, but it is gelatinous. We know zinc hydroxide precipitates are white, but they are gelatinous in nature. But this is not sufficient, right? Because see, white in color, this is also white in color, gelatinous. So it's difficult to figure out, right, that which one of them would be the calcium salt solution and would be the zinc salt solution, because both of them are giving us the precipitates which are white in color, though one is of gelatinous nature. But what you can do is, see, you can make this thing more clear in order to distinguish. How? By adding excess of NaOH, because we know that when we are adding excess of NaOH, calcium hydroxide precipitate is sparingly soluble, right? So yes, if we can make more clear, then we can. Okay. See, in the case of calcium and zinc salts, we can make it more clear to distinguish. If this was zinc salt and lead salt, then it would be somewhat difficult, right? Because zinc salts also give us white PPT, which is soluble. Lead salts also give us white PPT, which is soluble. Now in that way, the only distinguishing point is the white PPT which is found in case of zinc salt is gelatinous, and the white PPT which is formed in the case of lead salt, it is chalky in nature. So that would be the only point of distinguish. That would be the only point of difference, right? But here we are having some more point, na? Because see, calcium hydroxide precipitate is sparingly soluble. It is slightly soluble in excess of NaOH. But this zinc hydroxide precipitate, it is completely soluble, right, in excess of NaOH. It is forming that sodium zincate salt. So this difference we can easily make out. So try to write the answers in such a way that your point is easily conveyed to the examiner. Okay, there is no point of confusion there. If you would stop here itself writing the answer, then maybe you won't get complete marks. Okay, so what you have to simply write is same way what you have figured out. Add NaOH solution in both of them. In both of them, I am adding NaOH solution. Now, one which forms white precipitate, okay, which is sparingly soluble in excess of NaOH. See, sparingly soluble in excess of NaOH is the calcium nitrate solution. And while one which forms, okay, gelatinous white precipitate, see, gelatinous white precipitate, which is soluble in excess of NaOH, okay, is soluble in excess of NaOH, okay. is of zinc nitrate solution. Simple. So you have to just write the same thing which you are trying to figure out. Okay, but when you are writing those things, you should not miss the key words. And when you won't miss the keywords, when you know the concept clearly. Okay, this white precipitate. Okay, the color of the precipitate, the nature of the precipitate. See the gelatinous white precipitate. These things, if you would miss, it would clearly indicate that you are not thorough with the concept. And also, if you would miss these terms, then you are not writing the correct answer. Okay. So now another type of, means the same type of question, the next question. Okay, we are having another two pairs of compounds. We now have to distinguish with the help of a reagent. So ammonium sulfate crystal, sodium sulfate crystal. Now you have seen that ammonium sulfate crystals and sodium sulfate crystals. So we have to just think that which reagent would give us some different reaction with ammonium sulfate, and that same reagent should give different reaction with sodium sulfate. Okay, so in this chapter we have studied the action of sodium hydroxide on ammonium salts, right? And in the previous chapter as well, when we were studying the properties of bases, okay, we have studied the action of alkalis on the ammonium salts, right? So this topic we have studied twice, right? And this is only we have to apply here. See, the ammonium salts, when we would treat it with sodium hydroxide, we know what is going to happen. This reaction gives us salt water and ammonia gas, right? But when we would try the reaction of sodium hydroxide with some sodium salt, suppose sodium sulfate, right? Na2SO4. So this won't give us any reaction. Okay, so this is, we have distinguished between these two salts. See, so we have to simply write the same thing. Now the problem here is, we know that ammonia gas gets released, but we cannot write it in the exam that way, because ammonia gas, when it is getting released, it won't say I'm ammonia, right? We have to write a test for that gas the same way we have studied it for the acid, base and salt also. Such type of questions we have to write a test for that gas. So we know that ammonia gas, I have told you deliberately in this chapter, okay, when we were studying the action of sodium hydroxide on ammonium sulfate, on ammonium salts, okay, I have told you that ammonia gas has a very strong, sharp smell, and what we call that smell as pungent smell, right? And this is also a colorless gas. Okay, you have to remember this thing. So you have to simply write that when treated with sodium hydroxide solution, okay, see, one which gives pungent colorless gas, see, one which is giving pungent colorless gas is ammonium sulfate, right? Ammonium sulfate crystals. And one which gives no reaction is sodium sulfate crystals. Very simple. Okay, just you have to pay attention on the details of the answer. Okay, and you won't miss it. I have always emphasized, I know the keywords are very key in your marks, but I have always emphasized this thing that you just study the concepts with clarity. Okay, once you know the concepts in clarity, you won't miss any keyword. Okay, and if you won't miss any keyword, your marks won't go here and there, right? So moving to the next question. Now, identify the salt Q from the following observations. This was asked in 2020. Okay, previous was asked in 2020 also. Okay, the previous question. This question was also asked in 2020 and the previous one was also. So, what is given about the salt Q here is, salt Q is white in color. Okay, fine. On strong heating, it produces buff yellow residue. Okay, fine. And it liberates, on strong heating, it liberates reddish brown gas. So, this part you would study when we would actually study the decomposition of nitrates, which we are going to study in your chapter study of compounds, nitric acid. Okay, so no need to pay attention to this part here. What I am trying to tell you is that some questions are asked in such a way that they club the concept of the two chapters. Okay, so this is the concept of some other chapter which we are going to study ahead. Okay, 8th chapter. Now this is the concept of this chapter. Okay, solution of salt Q. So what we are going to do is, we are going to try to figure out from this part the salt Q. Okay, whatever part we can figure out, we can figure out. Rest part from this point, which part we can figure out, I would tell you later. So first let's try to figure out from this sentence which is this salt. Okay, so what is given to us? Solution of salt Q produces chalky white insoluble precipitate with excess of ammonium hydroxide. Okay, so let's go one by one. Okay, first they are saying the salt Q solution is producing chalky white precipitate. Now it should be clicked in your mind. Once you see the chalky white word, it's lead hydroxide, correct? White precipitate and chalky in nature. So yes, they are saying us that this lead hydroxide precipitate is forming, and what else they are telling about this precipitate is this precipitate is insoluble with excess of ammonium hydroxide. So is it true? Just try to remember, try to connect this thing. So let's verify. Is it insoluble with excess of ammonium hydroxide? So we know that with excess of ammonium hydroxide, only zinc hydroxide and copper hydroxide are soluble. Lead hydroxide is then definitely insoluble, right? So this is also correct. So yes, we got our precipitate. Now what they are telling us is the solution of salt Q is producing this precipitate. Okay, by addition of ammonium hydroxide, and this precipitate is insoluble in excess of ammonium hydroxide. Now which salt solution would produce this lead hydroxide? We have figured it out, right? In the same way we figure out that which metal ion is present in that salt solution. Now since lead hydroxide is getting produced, this means that we know in lead hydroxide Pb2 plus ion is there. So this Pb2 plus ion is coming from such a salt solution which is having Pb2 plus ion. Okay, such a salt solution whose salt is having Pb2 plus ion. So see, for salt Q, we got its one ion, okay, which is Pb2 plus. Now the second ion, which is the negative ion of this salt, we would get it from this part. Okay, so I'm just simply telling you it is a nitrate. Okay, so nitrates are having NO3 minus, sorry, okay, NO3 minus ion. So from this part we can say that the salt is a nitrate salt, and nitrate salts have this NO3 minus ion. From this part we have figured out that the salt is having Pb2 plus ion. So now it's simple, we have to just club Pb2 plus ion and NO3 minus ion would form lead nitrate. Very simple, PbNO3 twice. So this is the salt Q. So such questions are also asked, okay, where you have to apply the concepts of both the chapters. Now moving on to the next question. See, copper sulfate solution reacts with sodium hydroxide solution. Okay, copper sulfate solution reacts with sodium hydroxide solution to form a precipitate of copper hydroxide. Okay, according to the equation. So they have given us the equation. Now what they are asking us, what is the color of the precipitate formed? Very simple. Okay, now we have summarized the entire action of sodium hydroxide and ammonium hydroxide on metallic salt solutions. We know the precipitates which are formed, which hydroxides are formed as precipitates, right? And we know the color of the precipitate as well. So copper hydroxide's color, what is it? Means what? Which color was for the copper hydroxide precipitate? Or what is the color of copper hydroxide precipitate? It is pale blue, right? This is our answer. Simply, they are just asking us the color of the precipitate. So such simple questions can also be asked. Okay, but you need to know the color. That's why I was emphasizing on color so much. Okay. Now next is choose the correct answer from the options given below. This was asked in the 2017 exams. So a chloride, a precipitate that is soluble in excess of ammonium hydroxide. Okay, now they have given us 4 chlorides as the options. First of all, now let's try to figure out that do all these chlorides which are given to us, do they form a metallic salt solution itself, right? Because if they won't form a metallic salt solution, then they cannot react with ammonium hydroxide. Okay, right? If the chloride is not forming a solution, if it is getting settled down in the water, then it cannot react with ammonium hydroxide, right? So it's the first condition. Now see, we know that we have to apply the rule that all chlorides, bromides, iodides are soluble. Exceptions are lead chloride, mercury chloride and silver chloride, right? Means the chloride of mercury and silver chloride, right? So calcium chloride, ferrous chloride, ferric chloride, copper chloride, they are not in the exceptions. This means all these chlorides are the salts which are forming, which can form solution, because all these chloride salts are water soluble. Okay, so yes, now all of these 4 have passed the first test. Okay, fine. Now they can form this metallic salt solution. Okay, now the second point we have to figure out is they are saying that it is forming a precipitate. Okay, leave about this, that is soluble in excess of ammonium hydroxide. It is forming a precipitate with ammonium hydroxide. Okay, so just let's try to check out which of the following chloride solutions, okay, metallic chloride solutions are forming precipitate with ammonium hydroxide first of all. Okay, if 4 of them are passing this test, then they are like compatible with this point as well. Okay, this condition as well. Now see, calcium chloride, ferrous chloride, ferric chloride, copper chloride, which means calcium salts, ferrous salts, ferric salts, copper salts. Okay, now this salt solutions, we know out of this calcium salt solution, when we are treating it with ammonium hydroxide, do they form precipitate, right? No. Yes. So this salt solution will not form precipitate, so it would be now out of the question. So this cannot be our answer. Okay. Now we are left with the 3 options. Now let's try to figure out that out of these 3, which one would follow this condition. The one which follows this condition, this is the last condition now. Then it would pass all the tests, and that is our answer. Okay. So the last condition is this precipitate is soluble in excess of ammonium hydroxide. So out of these 3 salts, which salt gives us a precipitate which is soluble in excess of ammonium hydroxide? So we know ferrous salts give us ferrous hydroxide precipitate, ferric salts give us ferric hydroxide precipitate, and copper salts give us copper hydroxide precipitates, right? Now out of these 3, which precipitate is soluble in excess of ammonium hydroxide? Try to remember. In case of ammonium hydroxide, and we are adding excess of ammonium hydroxide, only zinc hydroxide and copper hydroxide precipitates are soluble, right? So out of these 3, we know that only this is soluble, and this is formed by this copper chloride solution. So our right answer would be copper chloride, right? This chloride is forming a precipitate, okay, which is soluble in excess of ammonium hydroxide. Very simple. Okay, so in this way you have to reach out to the answer. You have to apply the concepts. So see, this question we applied throughout all the concepts which we have studied so far, right? The solubility concept, the precipitate formation concept, and the concept of adding excess of that reagent into that particular solution, so that we have to see that the precipitate is getting soluble or not. Okay, so with this we have reached the end of this video, and I hope you would have understood all the concepts which we have learned so far, right? And you would have enjoyed learning with me. But please do let me know this thing in the comment section. And जैसे कि आप सभी को पता है, LearnoHub मतलब फ्री है पर बेस्ट है. So see you in the next video with the remaining concept of this chapter. Till then, stay tuned. Bye bye and have a great day.